Hello, physics fam. We are back and we're talking about projectiles with horizontal launches. This is worksheet 10-1. Let's do a couple examples together. And as you know, question number 1 already has an example problem showing you what to do. But let's jump into it. Looking at question number 2, Billy stands on a bridge kicking stones into the water. If the stone with a horizontal velocity of 3.5 meters per second. So first of all, if we're thinking about givens right away, the velocity in the horizontal direction, so that's Vx, is going to be 3.5 meters per second. All right, that's given to us. And it lands in the water a distance of 5.4 meters from where we were standing. So that means the distance in the x direction away from where that object started is 5.40 meters away. So that also is a piece of information. We want to know really what is the height of the bridge then. So by the height of the bridge, what that really means is we want to know in the y direction, the vertical direction up and down, what was the distance that rock or stone actually falls, right? So we have to start translating what they're asking and manipulate that to fit the equations we know for projectiles. And we know that we split the x and y component up. But the distance the rock would fall or stone would fall would be the distance in the y direction. Don't forget though, if anything is falling, we've got gravity as well. So that might be something we can use, negative 9.8 meters per second squared. All right, but we have all that information. So we need to start thinking about what equations might we be able to use. Now remember, in the y direction, the distance the stone would fall would be equal to 1/2 times the gravity times time squared. We also have to remember though in the x direction, we know that the velocity in the horizontal direction is really equal to the distance in the x direction the object travels times time. Now that we have those two equations and we eventually want to solve for the distance in the y direction, we unfortunately do not have the time right here to plug in to solve for our dy. But we do have enough information in the x direction to solve for time and then plug in to dy. So that's what we're going to do. We're going to use one equation, solve for it, to plug into the other. So let's go ahead and do that. If we use this equation, Vx equals dx over t, we can start plugging in. Vx is 3.5. The distance in the x direction is 5.4 meters, and the time we don't know. But we can solve for that. We know we need to multiply time to both sides. So time cancels out. Time times 3.5 equals 5.4. To get time by itself, we're going to divide both sides by 3.5. Get rid of that. And our time ends up being 5.4 divided by 3.5, which ends up being about 1.54 seconds. Now we've got time, but that's not what we want. Remember, we want the distance the stone's gonna fall to know the height of that bridge. But again, we can plug that into our y equation. And let's do that. I'm going to change up my color so we can see it better. But let's use this equation now. So dy we don't have, we're going to solve for that, equals 1/2 times gravity, which is negative 9.8, times the time squared, which is 1.54 squared. Sorry, I'm squeezing it in there. But let's do our math. If you do 1/2 times negative 9.8 times 1.54 squared, that number ends up being negative 11.62. So what does that mean? Why is that negative? Well, it means that the stone fell 11.62 meters. So really, if we want to know what is the height of this bridge, you technically don't need to use the negative. It's 11.62 meters high. But the math gets you negative because we know displacement has a direction, and in this case, it's downwards because the stone falls. But in the end, because of those two equations, you were able to figure out and pick up the fact that the stone would fall about a little over 11.5 meters off that bridge. So use those two equations. If you need one, solve for one to get to the other, and you're going to find that you're going to be able to solve for a lot of these. Hope that helps. Let's go to another example. Question number 3 has a pilot drops a bottle from a plane. If the plane from which the bottle is dropped is flying at an altitude of 500 meters. Okay, so let's start thinking about this. A plane is 500 meters above the ground, so if you drop that bottle would drop negative 500 meters in the y direction, the vertical direction. And if that bottle lands 400 meters from its initial dropping point, that means the distance or displacement that bottle fell was 400 meters forward. So that is also information that we could use. We want to know how fast was the plane flying when the bottle was released. So how fast means that we're looking for the plane, how fast it's moving in the x direction. Again, we have to read to understand and then manipulate our data to plug into our equations. Don't forget, if anything is falling, we remember that gravitational acceleration on Earth is negative 9.8 meters per second squared. Let's think about that. We know our two equations. If an object is falling, we know that 1/2 times gravity times time squared allows us to solve in the y direction. And eventually we're going to need the velocity in the x direction is equal to the displacement it went divided by time. So I need to solve for this. The only problem is I don't have time yet. So I can't just do displacement in the x direction divided by time. But I do have enough information to solve for time in this equation. So let's solve for time in this equation and then plug that into this one. So we need two little problems. So let's go ahead and do it. Let's start with this equation. Distance in the y direction equals 1/2 gravity times time squared. All right, the distance in the y direction, it drops 500 meters. We know 1/2 times gravity, which is negative 9.8, times time squared. Let's put that together. Let me change my color here just to keep things tidy. 1/2 times negative 9.8 is negative 4.9 times time squared. That's my 500. To get time squared alone, I'm going to divide by negative 4.9 to both sides. See you later. Time squared is equal to negative 500 divided by 4.9 equals about 102.04 is what I got. Notice negative divided by a negative means that's positive. That's good and important. We cannot square root a negative number. And time ends up equaling about 10.1 seconds. All right, so we solved for time, but unfortunately that's not my answer. I need that time to plug into my equation so I can solve for the velocity in the x direction. So let's go ahead and do that. My velocity in the x direction I don't know, but I do know the displacement. It went 400 meters forward from the drop, and I do know my time now is 10.1 seconds. So this becomes nice and tidy and straightforward. I just need to do 400 divided by 10.1. I end up getting about 39.6, and since it's the displacement meters divided by the time, seconds, becomes 39.6 meters per second. So that means that airplane, let me draw it a little bit, must be going about 39.6 meters per second forward every second from according to what the data says in the beginning here. That's its horizontal velocity. But again, we use the two equations to help us use one and plug into the other, right? Hopefully that helps you. Okay, fam, let's do one more example here. Number 4, Tad drops a cherry pit out the car window 1 meter above the ground. So given we know the distance that cherry pit's going to fall in the vertical y direction is 1 meter. And if it's falling, technically it's negative, right? Now, you're traveling down the road at 18 meters per second. That means when you're driving down the road, you're moving in the horizontal plane, the x direction. That means your starting velocity is 18 meters per second. We want to know how far the initial dropping point does the pit hit the ground. So what does that mean? That means if we drop that pit, how far or its distance or displacement in the x direction will it land from where we let go? So that's what we're going to be looking for, the distance or displacement in the x direction. Don't forget, we always know gravity is negative 9.8 meters per second squared, just in case we need it. And as you've probably figured out already, we can use both equations. The displacement in the y direction is always equal to 1/2 gravity times squared, and the velocity in the x direction is always the displacement in the x direction divided by time. Now I know that I'm trying to solve for this, so I need Vx and t. I have Vx, but I don't have t, so darn it, it looks like I'm gonna need to use this equation, solve for t, to plug in there. So I'm gonna have to do two equations again. No problem. Let's start with this equation. My dy is negative 1.0. It's times 1/2 times gravity, negative 9.8 t squared. Now we know 1/2 times negative 9.8 is negative 4.9. You've probably run into that so much you've memorized that. I am going to divide 4.9 to both sides because I want to get t squared all alone. Negative 1 divided by negative 4.9 ends up being about 0.21. I have t squared. That's not my answer. I need t, so I need to square root that. My t ends up being about 0.45 seconds. 0.45 seconds. Sorry for the sloppiness. My fingers are a little fat. All right, now that I have that time, I'm going to plug that into my equation. So we can do that. Let me get a new color and draw a little line there to give some space. Okay, so I'm going to use Vx equals dx over t. Vx is 18 equals dx, distance in the x direction, I don't have, divided by time, which is 0.45 seconds. Double check my writing. Yep, 0.45 seconds. How do I solve for that, friends? Ooh, I just have to multiply 0.45 over to both sides. 0.45 will cancel out. Distance in the x direction will be left. And I do 18 times 0.45. I end up getting about 8.1 meters. So with you in that car, you drop that cherry pit. You're going about 18 meters per second, pretty fast. That cherry pit's going to fly forward about 18.1 meters before it hits the ground. And again, we use both of our projectile equations to make that happen. All right, physics fam, hopefully that's helped walk you through. You should try a couple on your own to really make sure you struggled through, then check your answer key and any issues you have after you struggled through it. Make those corrections, ask those questions. That's how we really learn. That's called desired difficulty. We want to be able to learn from our mistakes, and that's how our brain actually remembers it better. All right, guys, love you. Take care. See you soon.